is, in the last lectures we have defined different activation functions used in the neural networks. Now in this video tutorial we will implement the different activation functions using neural networks, how these different functions will be implemented, and then how they will be used in the neural networks. For this purpose, we will classify MNIST handwritten digit classification data sets. This is a very short, brief introductions that what is handwritten digit classification data sets, how many records are there, and how many target level R class are there. So if you look at this, the MNIST data set is an acronym that stands for the Modified National Institute of Standard and Technology data set. It's a data sets having 60,000 small square 28 by 28 pixels grayscales image. So there are 60,000 images of grayscales of handwritten signal digits between 0 to 9. So means 0, 1, 2 up to 9, total digits are 0 up to 9, and they are differently written in this data set. So the total number of images are 60,000. The task is to classify a given image of a handwritten digits into one of the 10 classes. So means we will pick an image from the data sets and will classify that this image will belongs to class 0, 1, R up to 9, so any class representing integers value from 0 to 9 inclusively. It is widely used and deeply understood data sets, and for the most part is solved. Top performing models are deep learning convolutional neural networks that achieves a classification accuracy of about 99%, with the error rate between 0.4% and 0.2% on the hold out test data set. So now here we will also use the neural networks and we'll see the accuracy over this handwritten digit data sets. So for this purpose I need some library that is important. Libraries are two, TensorFlow and Keras. So what is TensorFlow and what is Keras? If you look at this, yes, okay, TensorFlow. TensorFlow is an open source end-to-end platform, a library for multiple machine learning tasks. So in short, you have to keep in mind this, that TensorFlow is a library equipped with the multiple functions, with the multiple tasks that can be performed on different machine learning algorithms, while Keras is a high-level neural networks library that runs on top of TensorFlow. So if you look at this, first we import TensorFlow and then Keras. So Keras is basically both provide high-level APIs used for easily building and training models, but Keras is more user-friendly because it is built in Python. So they are high-level APIs, libraries enriched of different functions to be used in different machine learning algorithms. So then we have to load the MNIST datasets. MNIST datasets. This is keras.dataset.mnist.load data, and then we want to show load the MNIST datasets. Here we have simply load the datasets, and then the dataset is divided into X-train, Y-train, X-test, and Y-test. So what is the shape of now X-train? How many samples will be there in X-train, Y-train, X-test, and Y-test? So let's see. So if you look at this, even I'm going to run this. If you look at this, there are 60,000 samples in the training data sets, and 784 are different features of pixels, and 10 are the number of classes inside the data sets. Okay. So now if we want to print the shapes of the data sets, then 10,000 in the X-test, with the 28 by 28 features, and then Y test there are 10,000 samples. Similarly, pre-process the data because the data is in pixels form 28 by 28 in a grayscale. So we want to pre-process the data. After pre-processing the data, what will be the output? So if you look at the training data sets, now there are 60,000 samples with 784 different pixels of features. So this is basically we want to reshape them in a one channel or in a one link. So then After that, we want to show that y train, y test, x test, and then we want to convert labels to one hot encoding schemes. For this purpose, this is the y train shapes, and this is now the y train shape. And then the main task, we are not here concerned with the converting either with the pre-processing steps inside the data sets. As we have covered a lot of videos in the playlist of data science and machine learning. So here our main task is to use or implement different activation functions, and how these activation functions will be used inside the neural networks. So this is very simple. We define the activation functions, define sigmoid. Here we have defined a sigmoid function, and then return 1 plus 1 plus np by x minus x. So what is this x? How these x will becomes? So these are the different activation functions. How these activation function will be called, from where these activation function will be called, look at this. So here in this case, we first want to build the model. So model Keras dot sequential layers dense 1 to 8 input shape 28 by 28 activation. So here we used activation functions of relu in the hidden layers, while in the output layer we used the softmax functions, as we discussed in the last lecture about in detail that what is relu functions, how, why we use it, and then what is the softmax functions and how we use it. So if you don't have a background of softmax and relu functions, please consult with the previous lecture. So then, okay, let me run it. Okay, now okay, now we have to compile the model. Model dot compile optimizer Adam loss categorical cross entropy and matrix accuracy. So let me clear one thing. This is basically the hidden layers we have used here in classification the hand digit data set sum by using relu activation functions, while this is the output layer of the neural networks. So here I am going to compile this. So now what is Adam and what is categorical cross entropy? Adam is basically a popular algorithm in the field of deep learning because it achieves good result fast. Basically this is optimizer algorithms which is used in different deep learning algorithms because it achieves good result faster. If you want to achieve better results, then we have to use the Adam. There are different multiples optimizer functions. The categorical cross entropy loss functions will be optimized suitable for multi-class classification. If you are going to use if you are going to classify a multi-classification problem, then you have to use categorical cross entropy loss function, and we will monitor the classification accuracy metric which is appropriate given we have the same number of examples in each of the 10 classes. Obviously this we will look at the accuracy metrics and then okay from here we want to fit our model. Training the model, model dot fit x train y train. We must train our model by providing the samples from x training data sets and y training data sets. Epochs 5 batch size is equal to 32. So what is the batch size and what is the epochs? Look at this. Epochs, it represents how many times you want your algorithm to train on your whole data sets. So here I provide 5. You can provide by your choice 1, 2, 3 up to 4, 5 up to so on. Again, the number of epochs depends on the kind of data and task you are facing. An idea could be imposing a condition such that epoch stops when the error is close to 0. Obviously, there is no further needs for the training if the error rate becomes 0. Or more easily, you can start with the relatively low number of epochs and then increase it progressively, tracking some evaluation metrics like accuracy. Or even you can even start from 1 and then look at the results, accuracy metrics, and then gradually increasing up to so on up to the maximum point where you can achieve a maximum accuracy. Similarly, the batch size. Many batch size, when you are facing billions of data, if you have a large number of samples inside the data set, it might result inefficient as well as counterproductive. Feeding your neural network with all of them. A good practice is feeding it with smaller sample of your data. So what does it mean? If you have a large number of data, it will be better to provide a small number of samples as a training data sets called batches. So now here how many batches we provided? 32 batches, means the whole data sets, we have a very huge large amount of data sets. We divide these data sets into different training data sets with the batch size of 32. So by doing so, every time the algorithm train itself, it will train on a sample of the same size of the batch. The typical size is 32 or higher. However, you need to keep in mind that if the size is too big, the risk is in overgeneralized model which wouldn't fit new data well. So you can even write the batch size up to 50 and so on, but this is the standard batch size which is 32. So why we use it? Because the risk is in overgeneralized model which wouldn't fit new data if the size is too big. If yes, we can write the batch size is 40, 45, 50, even 100, but in this case there might be a risk that the resultant model will not be a generalized model. So then how to call the activation functions? Here if you look at this, yes, here I used the activation functions. Now activation relu, here I am used a relu activation functions. From here that functions relu functions will be called. If you look at this, this is a relu functions, and from there a relu value will be passed, and then this will returns by the maximum 0 and 1, means backend calculations or backend processing will be performed, which will returns the classifications in a range of 0 and 1, because relu is used for the predictions of the classes having range of 0 and 1. Similarly, for the output layer we use the softmax. From here the softmax function will be called by supplying this parameters. After the backend calculations, we will this function will return the proper classifications, whether a proper image is belong to class 0, 1 or up to n. So this is basically very simple models, and it gave us, if you look at the accuracy, it gave us an accuracy of let me clear one thing from here. Since we used here epochs 5, so if you look at this 1, 2, 3, 4 and 5, so this is the epochs. 5 epochs means 5 phases of training. Here loss is that one, accuracy is that one. So we here the batch size, in a batch size we used a term that if the loss become 0, then stop the training process. So now if you look at the accuracy, accuracy is 0.0069% total loss, that, and total accuracy 0.6. So we are here not concerned with the accuracy, that how much the data will be accurate. We are not here concerned with the accuracy, that how much our system or classifier is accurate. We are just here concerned how to implement the different activation functions we have used here. So for this lectures this is sufficient. I think in the next lectures we will use the activation functions, the different activation functions or multiple data sets to show the result. Thank you very much.